Hey folks, welcome to another episode of Entra Chat. And today I have Tarek again with me. And this time we're going to talk about an awesome topic on Entra resilience. It's been a while since Entra has had a global outage. I hope we don't jinx it with this episode of the podcast, Tarek. But yeah, there are lots of cool stories and what happened behind the scenes. And how Entra has evolved over the years to address these different things. And we're super lucky to have Tarek here to, talk about that and share all the stories. Tarek, let's kick things off.
Yeah, hi everyone. My name is Tarek Dawoud. I'm a lead architect in the customer engineering team. For full disclosure, I am Meryl's boss. He is forced to do this. He doesn't want to do this. He has no choice.
Yeah. Tarek said, this episode you're doing this.
Yeah. This is his connect. He has to do this. And then, one of my favorite things being in the tech industry, right, is life-site culture. In some ways, it can be a very painful thing. Especially it becomes a drag when you have bad life-site culture, when you get alerts that are not real, noisy, that kind of stuff. But I enjoy real life-site, which is as an outage. And I've been I grew up in Entra engineering in the MS-ODS core store. I've been involved in my own share of outages, and years later, I'm sure many of your listeners, they relate to this, like, the domain controller incident of 1993, or I'm not sure there was a domain controller of 93, but it becomes a thing you bond over and kind of get close. And one of the things I like the most is just like the decision making and the quick thinking that you have to have at that moment. I thrive on that. I enjoy it a lot. So
nice.
I just wanted to bring some stories from growing up in Entra, and specifically tied to customer resilience and why customers should expect better resilience from us. So I will actually lead with some of the fluffy stuff that you see marketing talk about and all this stuff, but to build up to why you should have higher faith. But anyways, that's the intro.
Tarek, this word live site, I had never heard of it before until I came to Microsoft. It's we just say
OCE,
outage.
What do they call it?
Right? I think in the software engineering world, it's a common terminology, but we just say
and there are different words. Like I think
room
OCE, on-call engineer, and then I discovered there's DRI, directly responsible individual.
Yes,
different people call it different things in different companies as well, like Amazon versus Google versus Microsoft. But to me, live site means like there's an outage going on right now, and it's a very different world where your number one priority is mitigation. It's not fixing. It's not root causing. Like you sit on a bridge and people will be like, "How did this happen?" But people will be like, "Get off the bridge. We'll tell you later." You're not helping right now. So it's I really enjoyed, and you create these memories. Like I'll tell you. So I was a member of the OG DirSync team, right? AD Connect,
right?
Entra Connect, right? This is 2008, 2007, 2009. And there was one incident, for example, where we broke sync for Microsoft specifically. So this is in what we call dog food. So the world is not, this is BPOS, before even Office 365. But it's the same sync engine. And this was based on MIM, for those of you your audience who was familiar with Microsoft Identity Manager. And we were, there was a bug in the server-side code that disallowed the sync to continue. So the sync has been stuck for a few hours. Nobody's noticing in Corp. People left for the day. And we see it. Because we were running the sync ourselves as engineering team. And we're like, oh crap, this thing is down. And then of course, eventually, IT is going to notice that, changes are not replicating to the cloud and there's a problem here. And then we realize it's a server-side bug. And of course, it's going to take the developer hours to code the fix and then get through all the gates to get to production. But we also know that it's the shape of the data. It's a specific value on the way back from the cloud that's making the server barf. So if we hide it somehow on the object coming out, the server will not see the data anymore and will not be worried about the value anymore, and will move on with its life and be able to finish the sync.
Right.
And so we back then, this is not true anymore, but back then, AD connector DirSync, right, would create an export file before it exports everything. So it would, for
Right to
those
a
who are
file.
familiar with FIM or MIM, it would look at the source, In this case, it would look at on-prem AD, look at the cloud, diff the two together, decide what it's going to do, produce a file, and then push the changes out through the file. Now it doesn't do that. It actually does it in, object by
In the
object and runtime
database.
in memory.
Right. Oh.
And so we attached a debugger to the sync box and made it stop right at the moment when it's about to push the file out and edited the
Okay.
file and removed the properties. And we still laugh about it till today. Like every time we meet each other, none of us are in that team anymore, right? And every time we get together, remember when you were editing?
Editing the sync, hilarious. So did they do it every 15 minutes?
No,
Or
just for that one
it's just
export
a
to get
one
through
export?
for that
Right.
night while he fixes the code and pushes it to
Right.
production because like it was stuck for like a whole day. So that's why I call it war stories. Like I mean, obviously not to trivialize, these people who serve in military service, but like it becomes like IT people's war stories, like.
Yeah, true. Cool. And
Cool.
at Microsoft for live side, there are I didn't know this, but I mean, it makes sense that there are designated people who are always marked as being live side. It's a rotation.
That's it.
And
So not the same people always. It's actually every feature team has to basically have a bandwidth, a certain percentage who are assigned on-call engineers that week, OCEs or DRIs.
right.
And then they take care of live site while everybody else is working on features. And then for a week, there's one called a primary on-call engineer, a secondary on-call engineer. The primary usually is dealing with the outages. The secondary is usually dealing with the maintenance work. Like, there is a hot patch that needs to be pushed out, or there's a thing that needs to be done on the side, whereas the primary is the one sitting on bridges, troubleshooting. The secondary may be called up if there's two outages, for example. One is a SEV1, one is a SEV2. The primary will go to SEV1, the SEV2 will be go to the secondary. And it's a tax you pay. So if you have a team of 10 developers, one will be primary, one will be secondary, 8 will be working on regular engineering stuff. And if you're a bigger team, 20, there might be 2 and 3, that kind of stuff. And then the work is not done that week, so it's not like you're off the hook, because the moment you finish your live site, the first thing you have to do, remember that guy you kicked off the bridge and he told him not now. You have to do the RCA, the root cause analysis of what the hell happened, and the repair items, how you're going to fix them. Sometimes you own the repair items until you check them in. You don't just get to say, we should fix this. Someone or open an ADO item and just toss it on someone else. And so it's depending on the team and the culture, it's a big thing, obviously, and it's one of the things that people don't always appreciate about the rigor of software, especially cloud services software, right?
Yeah,
and it's fun, and it's also can be taxing as well, to be fair.
And I know that there's also an exec who is also responsible for the week, right? Like he gets put in.
We have something called I think I'm trying to remember the name. Like an incident manager all up for each big area, like for example, authentication or directory or whatever, there will be and they're for more to kind of make the bigger decisions. So for example, if the outage requires that we, shut down a service altogether or communicate to 100,000 customers that they're not going to be getting tokens for the next few hours, something big like that, then obviously we require some kind of, senior leadership to sign off on it. And then the highest level is obviously there are changes that we call the big red button, where you kind of need to override the safe deployment process to push a hotfix or a security or a patch real quick and stuff like that. And those need like VP approval, not even the senior incident manager can approve those.
Got it. Cool. Awesome.
Cool.
So let's kick things off.
So let's jump right in.
Yeah.
Okay, and I apologize for people who are listening to the podcast. There's a lot of slides and pictures. I do recommend you watch the YouTube video for this one. But I will also try to describe as much as possible. So we'll start off here this is the typical kind of more markety stuff where we talk about Entra's availability SLA. We promise a 4.9 SLA. This is something that I'm proud of personally. Very few SaaS vendors offer more than 3 nines. As SaaS, networking is different, but like SaaS providers usually offer 3 nines. We offer 4 nines, and fully recognizing that SLA means little when we do have an outage.
Yes.
Like if a customer take a dependency on us and they're down for an hour, they lose a lot more money than we give them back by paying them back for the 1 hour that they paid for Entra Premium or whatever, right? But to get to 4 nines, we have to run at better than 4 nines. That's kind of what the point of the slide here to say is that we publish this publicly. We share how we did every month publicly with everybody. It's not just a per customer thing. It's not internal. We do have per customer stuff, but we publicly transparently share with the rest of the world how we met our SLA every month. And you see here that we're been having a good streak. And I'm not a very superstitious person. I don't do knock on wood and this kind of stuff, but we have to be humble. It's not to brag as well, because in resilience, the number one, and resilience and security both. Yeah. And I say this generically for everybody who does a podcast or writes blogs or whatever. Never make fun of your competitors when they have a security incident or outage, because you will be next, always, just by definition, right? So just stay humble, right? But this is to say that there is some investment. So this is not just magic. This is actually the SLA. So for those who are not seeing this visually, this is the actual perceived SLA by the customer and the users, and the actual success failure rates at our authentication service level, STS, security token service. And we've had blips during that same month that we said we served more than 4 nines. But the reason is we have these, and this is the heart of the talk today, is we'll talk about a few war stories of Entra and what happened in them, big outages, and but to show how we've learned from them. And we have created these systems, these isolations, these backup systems, these kind of constructs that have allowed us to survive as more and more things have happened since, and we've been able to feel them less. That's the thing. It's not that cables stopped being cut. It's not that racks stopped going down. It's not that data centers stopped dying.
Yeah.
All these still happen. It is just that we've kind of put in these defense in depth kind of measures from a resilience perspective that have allowed us to arrive at this thing. So I'm going to kind of walk with you, hopefully today, and your audience about kind of 3 big investments we're going to talk about, and see how each of them contributes to this.
We look at what happened. Yeah, we look at what happened, right? That led to why we did these as well. Exactly. How these address them.
Yes. So as we're going through cell-based architecture, we will actually lead with the famous outage of 2015. We'll talk about some of your outages. We'll be like, oh, I remember I was trying to log in that day and I couldn't get my email. So that's why. So conceptually, this is a resilience slide we share with our customers when they ask us. This is actually a blog also by our VP of Engineering, Nadeem, who talked about these 8 principles. These principles are actually fairly ubiquitous among Microsoft services in general. If you talk to an engineering leader from Exchange, from Dynamics, they'll subscribe to most of these. It's just that for each service, sometimes you do something slightly different. So, for example, backup auth service is a very Entra unique specific feature, given the nature of authentication as a problem space. Yeah. An equivalent of that, for example, on Exchange side would be that they have this delayed mailbox replication as a capability, where there's one replica of mailboxes they delay replicating changes to in case there's a massive corruption. So it's like the fallback, the safety.
Oh,
right. So that's a very different feature. We don't have that one,
yes,
for example. Yeah. But because they're sitting on very important customer data that is stateful data that is very, very important, they actually do that, for example. So each service will have kind of unique kind of innovations, and then also kind of these common 7, 8 principles that apply all the time. So we'll start with the cell-based architecture one, which will be the bulk of the talk. And visually, we usually represent it this way. I don't want you to squint too deeply, other than to say that there's a beautiful rainbow chart on the right side of this picture that shows a big pie chart with nothing, no slice bigger than 1-2%. And that is the end message of this, is that there's not more than 1 or 2% of traffic being served from any specific Entra cell at any point in time. We're not putting a lot of eggs in one basket. We're going to talk about what a cell means and how did we arrive at that in the next section. But this is what this picture is like. And what we're doing here today is we're going deep into that little beautiful rainbow, into how actually how do you arrive at that. But to get there,
Yeah.
What I'm going to start with first is actually explaining some fundamentals about how Entra works, right? So this is specifically kind of generic, inaccurate, very old picture. In fact, some of you who see this visually will recognize this as an old website that's deprecated. It's not there anymore, right? It says 2020. But the concept I'm trying to show here is that Azure is everywhere. Azure data centers are everywhere.
Yeah.
Entra is not everywhere. Entra data centers are only in enough data centers to serve our customers and traffic per region, per our geo requirements and residency and whatever. Right? So we have a requirement, for example, to serve Japanese customers from Japan, Australian customers from Australia. But, for example, regular customers in APAC, we may have 2 data centers in APAC or 3 that serve this traffic, and we don't need to be in every place that Azure is. Same thing in Europe. You see so many data centers in Europe. We don't have as many data centers in Entra in Europe. Same thing in North America, right? So that's what this picture is saying. So what we do have in most Azure data centers is something called the gateway service, which we will expand upon in a slide or two. That is pretty much kind of our forward proxy that routes traffic to our actual data centers. If you're walking in Morocco and you decide to hit Entra for any reason, get a token, you will probably hit Spain. That's the closest Microsoft Azure data center to you. It will likely have a gateway service there. That one will find the nearest Entra data center, which may be in France or maybe in Ireland, and go get the tokens from that one and then send them back to you.
But that will go through the Azure backbone, right? Like once it gets into one.
That hub, the hub between the Azure data center will be on the backbone. Exactly. And so, and we'll talk more about these kind of routing examples in a second. Another thing I want to explain visually, for those who are listening, is the concept of the directory layer versus the STS. That kind of Microsoft Entra, and these are old slides, like you see the word AAD everywhere. It's very terrifying. Yeah. But the Microsoft Entra has replicas of your tenant per region. So if you're a US customer or an Americas customer, you're generally in the US. If you are an EMEA customer, so Europe, Middle East, and Africa, you are generally in Europe. And if you are a customer, east of that, you are generally in APAC, except Japan and Australia, right? And so customers will have, and those will be the stateful services that have your data, and on top of them will be the authentication layer. The thing we're trying to communicate here is that the authentication layer and the directory layer are not always kind of like, they're not the same service. It's not like when you had a domain controller and it was sitting on top of the DIT file and it was serving authentication, the same thing. They actually could be basically think of separate servers. There's one server with the DIT file and another server with minting tokens.
Right.
Cool. So let's expand on the gateway service. So to understand how the gateway service works and kind of how geolocation works in Entra, we'll walk through an example here. So this is an employee of a company in Japan. He is currently actually traveling in California, walking around in LA, I don't know. And he requests a token from Entra for whatever reason. What's going to happen is the closest gateway's data center to him will pick up the request. And that may be in Los Angeles. There may be an Azure data center in Southern California, right? So they go to Azure LA. Azure LA is where the gateway service is. That one says, okay, I know where the nearest data center to me is. It's in the one in Seattle. So let's say it's going to go to Seattle.
That's the Entra database.
That's the stack you see here, the US data center, the red one, right? Yeah. So it hits that one. That's step number 2. And it says, hey, can you please, and the gateway service is just a header rewriting service. So you hit login to microsoftonline.com/foo. All it does is rewrite that to internal URL.com/foo. And then when you come back with the response, it rewrites the header back and says, hey, login to microsoftonline.com is saying, and it gives you back the response, right? So it hits the authentication service. The authentication service is stateless, as I mentioned. It is an amazing token minting service that can mint tokens like nobody else can, sign keys. It understands how to parse OAuth requests, SAML requests, all that stuff beautifully, but it doesn't contain state. State is actually in the directory service. So hits the directory service and says, can you give me the artifacts I need to make this decision? So I need the app, I need the conditional access policy, I need the user, I need the blah, 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 the authentication methods. Give me all that stuff so I can start working on it. The directory of the service doesn't have the state of this customer. He's in Japan.
He's a user from Japan, right? His data is not
Japanese customers in Japan. So what it's going to do, though, it's not going to say no. It's not going to say 401. It will actually give a 302 and say, hey, so it has on its side something called a partition table. It has a full table of where every other customer is in the world. So it's able to answer and say, here you go. Here is this customer is actually in data center 3. Go there, right? So then ESS will send that response back to the gateway. The gateway will try the request against this other data center. This other data center will say, oh, lo and behold, I actually know what this customer did is, gives the artifacts back. The service serves the request successfully. The gateway will then set a cookie or a session or a cache on its side that says, okay, next time this guy comes back, I don't do this dance again. I know where to go.
Okay.
So it doesn't have to keep doing this every time you authenticate.
So the gateway has some state that it uses to.
Yeah, it's caching or
uses
cookies.
a cookie and right.
Yep. So this is important to understand because the gateway is a huge part of our resilience story. The gateway is not just for this nice, beautiful routing. Think of it as SDN, software-defined networking, right? This is the thing that an engineering manager on our side can decide to say, okay, send 1% of traffic here and 12% of traffic there. This is how they can move traffic around. They can say, fail everybody from east to west, from north to south. They can move things around without having to go to a router and cut a switch over and do any of that stuff. Log into a hub or Cisco or whatever. Nope, none of that stuff. It's very software. It takes care of all that traffic. Makes sense? So it's important to understand it not just in the geo-redundancy way, but also in the resilience perspective. And we'll show you how that works in a second. So now that we've explained this, we kind of walked you through these tiers here, right? So the gateway takes you to the STS. Below it, the STS takes you to the DPX. DPX is directory proxy. And probably most of your audience will not have heard that name before.
Yeah. No.
It is, think of it as a simplified version of Entra graph that is focused on what the STS needs. So coming in from MS Graph, you can request users, groups, you can filter by, source with, select statement, do whatever the hell you want with the directory. This is super optimized for what the ESTS wants. It's super optimized for queries about the user, the conditional access, to get the results of the authentication requests. That's it. If ASTS starts asking it about admin units, it will not answer. That kind of makes sense. So super, and this is also very helpful for your customers to understand about isolation. Graph is isolated from DPX. So when you're hammering away a graph with your bad apps, that does not affect your authentication traffic and vice versa, right? So it also is beneficial to the customers.
Because some people ask if I do too much of, Graph API, hit it too much, will it bring down users trying to sign in?
Yeah.
That's a common question I get all the time.
And the reads are served from a different set of front ends altogether. You are going to get throttled there, but it's not going to impact your users.
Yeah.
Cool. So now that you understand this, and below this you see the PN, P1, P26. This is the partitions where the customers live. So when you hit the core store, the directory stateful servers that I mentioned, we're not having everyone in a big bucket. It's not a good idea, obviously. They're all in scale units. Each scale unit contains a bunch of customers. You're not alone in your own partition. It's not a domain controller. I know many of your listeners will be very disappointed to find out that they're not just sitting in a domain controller in the cloud. It is not. It's a truly hyperscale multi-tenant service. And so, but it is still, there's a limit. Yes, we can take on more than one tenant with, even 1 million users. So to give you a sense of the scale, a single scale unit is about 50 million objects. 50 million objects, right? So typically, we will let customers sign every time, a new sign up comes in. Okay, so a customer signed up for Dynamics, a customer signed up for Office 365, a customer signed up for Azure. They all keep getting added to that partition until it gets to 25 million. Once it gets to 25 million, we stop adding new customers to it. We spawn off a new partition, and then that partition is allowed to grow organically, meaning as soon the customers in there will hire more people, add more objects, create groups, the partition is grown. If it starts to run hot, so it's getting close to 40 million or something, maybe we'll start moving customers off of. This happens silently, behind the scenes. Customers don't see it, don't have to file a request for it, none of that stuff. But this to give people an understanding of scale. 50 million is one scale unit, one partition in Entra.
Right.
Cool. Okay, let's get to the bad stuff. Well, the drama, the war stories, right?
The drama,
okay.
Yes.
So this is the infamous outage of March 2017. I was on the bridge of that one.
Okay.
This was a single customer in West Coast US. I shall not name them. It's not their fault. They did not, but I won't name them. I'm not at liberty to name them. But they made a conditional access policy. That's it. That's all they did. They made a conditional access policy that just had a criteria. I don't even remember. It was a group. I think it was a group expansion, right? So all what was happening is the request was hitting the STS to get a token for that customer. That user was in scope for the conditional access policy. The STS was asking the DPS to resolve, like, get me all the artifacts of all the people in scope for this. Is this user in scope or out of scope of this policy? Yes or no, right?
Okay. Yeah.
And DPX just asked the directory core store, "What, can you help me expand this group?"
Yeah.
And the core store was just like taking a long time. It's not that it wasn't answering; it was answering in 3 seconds.
Right. And usually that's how many seconds?
Milliseconds. So it's usually like 10 milliseconds, 20 milliseconds.
Right.
So basically, it was running hard. Like, this was a very hard question. And this is a latent code bug, and obviously on our side, right? Performance bug, right? And so, and again, it's passed all testing. Nobody found it in anything, but the customer created one CA policy. Like,
right.
It's called data shape, as you can see here at the top. Like, it's the shape of the data. It's not always easy to predict the shape of the data. You can always do your best to try and do end-to-end testing and unit testing, but customers will create, obviously, like
a unique
with Gen AI, you can even imagine this like 10x course right now.
Yeah, it's a unique combination of what data they had in their tenant and the CA policy they created.
Exactly.
That caused this.
So now we have a bug. So the partition is running hot, and DPX is waiting on the answer. Okay. So some of the requests, because this one is taking too long, waiting on the answer, ESTS starts asking the other side's fails over. And now I'm going to pause here for a second and talk about the pairing architecture. So what folks see in the picture here, and for those of you who are not or just listening, is we're showing 4 data centers with a service deployed in them, and the front ends and the back ends of the service are paired. So the front ends in the east and south are paired together, or west and south are paired together, and the back ends are paired together, and then the front ends of north and east are paired together, and the back ends are paired together. Right? This is called the pairing architecture. This is actually recommended. Like, this is what Microsoft, if you were deploying a new app in Azure, front ends and back ends, your CSAs, your cloud solution architects, would tell you, do this if you want high availability. Don't just put all your eggs in one basket. Yeah. Don't deploy the app only in ECOS 2.
Yeah, not in one region.
Yes. Exactly. If ECOS 2 goes down, you're down. Yeah. So please deploy it in ECOS 2 and ECOS 3, and maybe pair them together with load balancing, so you push people around between the two of them as you wish. So we've done that. We've done we actually did all that in this example here. And yet, we're starting to get in trouble now. So, as
it starts sending the load to the ESTS starts sending the load to the other one, or is it the gateway service that says,
well, in this case, it's ESTS. So gateway will start sending things around if ESTS is not responding to it. But this one, it's ESTS trying the TPS next to it and saying, hey, and it's running out of, it's waiting, and then the DPX is running out of handles below it. So the DPX is running out of, webhooks that's listening, waiting on MSODS to come back to it, the core directory to come back to it. So DPX is unable to respond. So ESTS is saying, I called this one server or this side, the US East, or, in this case, US West servers, and they're not answering me. Let me call the other side. Yeah.
So it runs that same bad query on the other.
Exactly. But unbeknownst to it, by doing that, it is killing the other side too. Right? So it's making things worse. I remember being on the bridge and one person saying, okay, let's just fail both sides to the other side all the way.
To the other regions.
And I remember, those are the cool things, right? The engineering manager said, how do we know it's not going to propagate the problem further? Right. And they were like, we don't know. And they paused, and they didn't. And it was saved the outage from being much worse, right? So those are the cool moments that you live for. That's, above the tools and above the telemetry and the stuff. It's kind of these judgment calls that you have to make right at the time in the moment, right? So that is problem number 1. Data shape, okay? And the traffic kind of running out of space basically because of the data shape. Second problem we had is a region down or a massive kind of outage. So think of it as protecting ourselves from infrastructure issues below us, right? Where at the end of the day, Entra is a SaaS, think of it as a PaaS or a SaaS, whatever.
Yeah.
We're abstracting away infrastructure from you. You're not managing the domain controller storage, the domain controller port, number of whatever, NICs. We are, but unbeknownst to you is we are relying on infrastructure below us, somewhere, right? There's no magic. Like there's a famous meme that says there's such thing as a cloud as somebody else's server, right?
So, yes.
So in this case, right? This is the infamous San Antonio outage of 2018. See, they're by names. This was, I think, October 2018, maybe September, I think. In this case, what had happened was the San Antonio data center in south central U.S. in Texas, right? There was a hurricane, tornado, something near it, which happens frequently in America. It's happening more frequently now with climate change, but and they decided to shut down the data center to save it, like to be safe. Like they were afraid that it was going to cause, hardware destruction,
and data
shorts and this kind of stuff. Yeah. So they pulled the switch. So it wasn't like, the outage actually just cut off, the trees flew off the way and cut off the cable. No, we purposefully said, nope, let's just shut it down. So not have electricity, somebody electrocuted by a cable flying or something like that. So they cut off, and that is a foreseen and planned scenario, right? We were supposed to be able to fail over. Nothing was surprising there. So now, all of a sudden, shut down a data center. So we moved over to the other side. The traffic all failed over. Now, think about a moment here about what you have to do. I think you referred to it here, right?
Yeah.
Is because you have to anticipate at any point in time in this pairing model that you can get all the traffic from the other half.
Yeah.
You have to run a 33% utilization, memory and CPU.
Yeah, this is like a fascinating thing for me, right? Like this means Microsoft is not very, like if you just think of it, you're like not very efficient, right? You're only using 33% of the compute and the server is idle.
Yeah, but
the rest of the time.
You have to plan for, you have to accommodate for, because you do have other things you do, by the way. So there's auto scaling, right? So you don't just sit at, okay, let me just fail everywhere. You also try to scale your number of front ends. But while you're scaling, you got to take on the initial burst of traffic.
Right.
So you can scale your number of front ends and back ends that you have, or if you need, right? You can't just say, I'm going to auto scale when I need to, because then auto scaling means you're spinning up a VM.
Yeah.
It's not instantaneous. It's not like
it takes time.
0 seconds. Right? So that means, you have to have enough room to take over the initial traffic burst and then scale up as needed, right? And I think most providers have to deal with this in some way. This number right now is better, and we'll show you why and how, right? But yes, you have to always plan for that, yep.
Yeah, so for reference, one customer I know, they have an on-prem IDP that they're running, and their servers are running at like 80, 90%, and recently they've got load and it's almost like at 95, 98% running hot.
And they're just playing with fire, right? They're just hoping no spikes happen, right? Yeah. And this is what actually, maybe this is a horror story for them to think about, is in this case, we fail the traffic over, and then another problem, again, another latent bug. Like I'm sure your listeners, especially those of you who've had a few years in, IT services, right? Whenever you've had any of these big outages, even within a single customer, right? You know that it's like lemony snickets. It's a series of unfortunate events, right?
Yeah.
It's never one thing that goes wrong that just takes down the whole system. Because when you do the RCA, the 5 whys, you discover that this was that, and all these conditions came together to make this a big outage, right? So, in this case, after the failover, there was an Office bug. Ta-da. And so we discovered that the Office client, so after the failover happened, the world woke up the next day. So the failover actually, when it happened, nothing was bad.
Right.
And we're now trying to spin up, scrambling to spin up and figure out, is San Antonio going to come back, or are we going to need a new data center? What else is going to go on? And everybody's like trying to figure things out. And so, but failover actually initially happened fine. But then customers woke up the next morning and started hitting our service and demanding tokens. and there was an Office bug. Nothing, not to slam the Office folks. It was a latent bug again, just like the conditional access bug earlier, right? Latent code bug is always there.
Yeah.
But in this case, it was a load amplification bug. The Office clients, when they were faced with a lot of throttling denial requests, would try harder.
Right.
That was the surprise for everybody, including functional, right? So it was hammering our service even harder and harder, and our service was having a hard time even having enough bandwidth to say no,
right?
Not to even serve the traffic. And so they basically kind of started kind of degrading the whole ecosystem again.
So it was an Office client sort of launching a denial of service thing by
exactly.
trying to sign in again because it
was basically our own product launching a denial of service against us, right? And I say these things not to obviously make light of anyone. It's just, I hope these things help your folks and your listeners think about how are they susceptible to these things, right? Yeah. You in your organization, even as you're sitting there listening, laughing about Microsoft and how silly we are, think about you have also client apps that your developers wrote. They're hitting your backend APIs that your developers also wrote. Are they susceptible to this thing? Will they become your biggest DDoS attackers if an outage happens or a bad guy manipulates them, right? So it's very interesting to learn all these things, right? And again, I was on the bridge of that one too. It was so this one was intense, right? We had to do lots of drastic measures for this one, and we learned from it, right? So now let's talk about what we learned from it, right? So what big changes did we want to make, right? Kind of these are the principles, right? That loss of an availability zone will not break the identity system. If a rack goes down, if a whole router goes down in an Azure data center, no, right? Azure region going down will not break us, right? A partition should be kind of present in two separate availability zones, so a customer is not served from one availability zone and they die if it dies, right? Failure of one partition should not drown out the others, like the 2017 outage, where one partition is struggling and is starting to poison the whole ecosystem, right? So, to answer that, we came up with this, right? So this is cell-based architecture. That basically, think of the rows in this picture as units of customers, right? So partitions or scale units of customers.
Right.
So FD1, FD2, think of them as the partitions of the customer. So each one has, 1,000 customers in it and it's serving them. And then the SUs are scale units of the authentication service. So basically every cluster of customers is served from 4 different scale units that are partitioned across all regions equally. So the big difference between the two slides is this big line you see at the top here. Now the gateway can serve traffic from anywhere to anywhere, can route the traffic from a guy who shows up here all the way over there. It's no longer hard paired as it was before. And so how does this play? What's the big deal? Think of it as I used to have a big monolithic service with a bunch of 1,000 front ends in US East and 1,000 front ends in US West, and now I broke it into 100 front ends in 20 data centers instead of 1,000 in 2 big data centers.
Right.
So why does that make a difference, right? Obviously, if a single gateway goes down, we're fairly immune from it. Even in the old architecture, we're fairly fine. Now we talk about a single cell of the STS itself as a problem, a code bug, whatever. You see that when it goes down, the load will be peanut buttered across the other.
Across more regions, right? It's not just like the 2 paired one.
Exactly. 3 cells, it gets peanut buttered. That's the thing. Yep. It's not a hard failover from here to here. It's peanut buttered across 3, which we'll talk about CPU utilization in a second. This is an availability zone. So this is a rack or a router, and Azure goes down and swallows everything that's running in that availability zone. Then again, it translates to 1 scale unit going down for each of the partitions, but all the partitions have backup they can go to and everywhere else. Make sense? And then this is the Conditional Access 2017 outage thingy, where a customer is drowning out everybody else in its partition. The partition is unable to resolve queries. They're still hosed. That's tenant 2 up there, the yellow tenant up there.
Yeah.
But at least their outage is now contained to them. No longer are these other SUs poisoned by this one kind of row that's bubbling up the stack and poisoning everything. Right. Tenant 3 and 4 and 1 are impacted, right?
It prevents one tenant causing like a global outage, right?
Exactly.
Like some issue in
set
just
of tenants,
one.
Right?
Yeah.
And then the final one is the San Antonio 2018 outage, where basically you can see here now the traffic gets evenly peanut buttered across the ecosystem back to the Microsoft running and not running very efficiently. In this new architecture, you can run these nodes each at 50% of capacity, because when this thing goes down, this one cell,
move to only one.
You peanut butter it, right? So you take basically, this is handling 25% of load, this is 25 of traffic, of customer traffic, right? So you take this one and you spread it across, it becomes 8%, 8%, 8%. So if they're running at 50%, they'll bump up to 60%. They won't feel the load. So now you can run with more CPU utilization and memory with this new architecture, actually more efficient as well, too, back to your point. So that is cell-based architecture. So anything you want to ask about this before we jump to the next thing?
Yeah, so this is one of the reasons why there are, like, we have these SLAs and there are all these global outages. But each tenant, I know when you're a Microsoft Entra customer, you can go to a Blade where you can see your tenant's SLAs. And that could be different to what's published as the global SLA, because it's a tenant-specific SLA, and that's sort of driven by part of the cell-based architecture.
It contributes to that, but I think everything contributes to you being able to.
Right.
And yeah, for those of you who don't know, if you go to Entra portal, go to health and monitoring, you can go to health under monitoring. And if you go to that health blade, there are two features. The SLA, the per tenant SLA. And this is actually for your tenant. But it's SLA, so it's not monitoring. What I mean is it's calculated at the end of the month. Yeah. It's not going to show you right now if you're out or down. It's actually meant to show you that for the last month, we met our SLA for you, or we didn't. And it's meant to help you use that with your leadership. When they read in the news, Microsoft had outage, and they're like, are we safe on Microsoft? What's going on there with this Microsoft thing? So you can actually go there and show them that we're fine. Or not, right? I mean, you can also say, no, we're not fine. Maybe we should move off, right? But you now have an evidence to show them, independent of the news, because the problem is every time we've had an outage or a near outage or a somewhat major outage, it will cause a fuss in the news. People will see status at Azure.com. There's an outage in Entra, and they're like, "Oh my, are we impacted? I think we were impacted." And of course, people in their mind will play kind of games with it, I had 5 support calls at the same time. That must have been the Entra outage. It could have been something else. We don't know. We can't prove one way or the other, right? So us publishing per tenant SLA helps, but to be fair, it's only for customers with 5,000 seats or more, I think. It's not just for anybody. So if you're a small customer, it gets hard to even compute SLA. And it's only authentication SLA. So we don't have SLA around, latency or other thing or rights or something. It's just authentication. Right. But it helps you build confidence in the platform. And it's part of our transparency with you. Like, we're trying to be more obvious. So we did publish the public one that says 4 nines and we're amazing. I shared that at the beginning. Yeah. But it doesn't matter if you have been impacted by it. It doesn't care. Like, you know that it's not true for you. So this helps you see what's true for you. The other tab in that UI is my favorite, which is scenario monitoring, which is real time. So, like I said, monitoring, Entra portal monitoring, and then you go to health. There's 2 tabs, SLA, and then scenario monitoring. And that one is real time health of MFA, device-based CA, that kind of stuff. That goes into every specific feature. Correct. Scenario. And it's near real time. I guess it's 5 to 15 minutes behind. It's really cool. Nice. Okay, so that's the first set of features. That's called cell-based architecture. Let's talk about the next one. The next one is something called the backup authentication service. And again, this is a very identity-centric example. Yes. So this I know because the incident happened after I joined in 2020, I think. Well, this has been around since 2018, since the big 2018 outage of San Antonio. It's actually been in development since even earlier, but it was under very limited use. But since 2018, we pushed it very hard. So what does it do? So what this is going above and beyond. So we did all this, fragmenting and cells and whatever to keep the service always resilient and nothing below it can take it down. But still, we can go down. And we can have potential large outages. So how do we even account for that? It's a unique authentication experience, which is the fact that we can, if done correctly, we can serve you tokens even though we're dead. Because authentication, most of the time, is a refresh of an existing thing you have. And so this is what this is about. It's about how can we continue to refresh sessions while our ability to check new artifacts and things like that is kind of degraded. So
I think just to step back for people who don't really know, like this plays into the whole access token and refresh token and how they work, right? You need to know a little bit. But the short story is even if you are like using Teams, you are not signed into Teams today, you didn't see the login screen. Almost every hour, it depends based on new things like continuous access evaluation. But typically every hour, every app you have is calling back to Entra and checking, is this person still valid? And then it gets a new token to continue accessing it.
Yes.
And Entra checks all the CA policies before it sort of gives a new token to that user saying, yeah, I'll give you access for another 1 more hour and you can get to things, which is why when someone leaves the org and you sort of remove them or disable the account, they lose access. That's what makes it possible for those things to happen.
And by the way, for your listeners, this is a kind of L200, L300 talk. If you don't know what tokens are, you should go watch the Intra Chat episode number 3. Or I'm just kidding. But to kind of build on what you said, for those who are unfamiliar, all modern authentication is tokenized. And this is why when you open your mobile app or you open your window and you're sitting on your Windows and you go to the browser and you go to your familiar sites, you're always signed in. You never do fresh authentication. You never type in your username. Yeah. In fact, you get pissed off when your banking site requires you to enter your password every few days, even though I just did it yesterday because it's a banking site, right?
Yeah.
But all the other sites are usually very friendly. And I don't recall the last time I was logged into any mobile app I have on my phone. All that is tokenized. What that means is you provide your credentials initially. After that, the authentication service gives you an access token to what you're trying to get to, and gives your app something behind your back called the refresh token. The app takes the access token and submits it to the resource. So go, for example, Netflix, after you log in, or let's not give Netflix, let's say Outlook or Teams. It logs in with Entra, but then it turns around and goes to Exchange to get stuff, right? Yeah. So it gets a token from Entra and goes to Exchange to get the stuff, the mail, the messages, the whatever. But under the covers, it keeps a refresh token with it. And then when the access token runs out, because it has to run out, that's how we know you've been, fired, or you've left the company, or you no longer own that role, or whatever. So we bring you back. That's how we bring you back. Because every hour we send you, we give you a very short-lived token, an hour, a day, 2 hours, whatever, depending on the app. But any of them, the access token is short-lived. Yeah. So when it runs out, the app doesn't just prompt you for username and password again. It's smart. It has a refresh token. It will submit that to the authentication service and say, remember this guy? Can you give me another access token? At that point, the authentication service could stop you. I'd say relog in again like the bank does. Or like most normal happy authentication services, they'll say, here you go, here's another token, nothing changed, keep going, right? That's how we keep checking that you're still allowed to do this without interrupting you as an end user.
And if you're an Entra admin, you can go to the sign-in logs. We have a tab that says interactive sign-in.
Exactly.
And you have this non-interactive tab. Yeah. So you can see almost like every app for a user will be hitting that endpoint to get
exactly. And so back to this, with how the two tie in together is the reality of, even though you're an Entra admin and you're creating all the CA policy and checking all these things, the reality is, and you're looking and you're staring at the sign-in logs all day, the reality is about 3%, no more than 3% of your actual sign-ins are interactive. 97% of them are non-interactive. Nothing is happening. It's happening in the background. No big deal. And so, and in fact, we as Microsoft, you may not agree with us. We actually think prompting for re-interactive sign-in over and over is just so frustrating to the end user. It's not a very good security measure. There are places like, checking for intent and checking for sensitive operations where it makes sense, like PIM or whatever. But in general, just having end users re-authenticate every 3 days or 5 days just to make sure it's still them, we don't feel it's a very effective security measure. But because of that, we're able to do something from a resilience perspective and identity that, other products and other things, mail or, Amazon or Amazon.com, like the shopping site may not be able to, right? And here I want to actually do a shout out to kind of like, the unnamed soldier, the unknown soldier or whatever in the war. I say this because a lot of folks, especially in podcasts, tech podcasts and whatever, there's a lot of celebrities, right? Don't see myself as one of them, you are. But others, right? So there's a lot of celebrities in our industry, people who talk in conferences and so on, they're celebrated, right? But I want to call out that for every one really smart or, talented person you see from Microsoft or Google or Amazon, whom, oh my God, he's a rock star, she's amazing, blah, 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 blah. You should know there's at least 10 really, really smart people behind the scenes that you never even see or hear about or talk to. Like in Entra, there are all these giants like Merli, Adrian, Raman, that people like Tarek walk into a room like, oh crap, Adrian is there. There are really these amazing geniuses who come up with some of this stuff, really, really cool stuff. Some of the names like Nadim and Igor, obviously they're amazing, right? But they're VP, so you kind of get to know their names. But there's all these really, really smart, amazing people that just want to come up with some of this stuff, right? Okay, let's talk about this. So, in the happy days, let me see, where am I? I don't know where I am. Let's try this one.
Yeah.
In the happy times, this is the user. She requests a token. Back to this token story we're talking about. Unbeknownst to her, she's using Outlook. Unbeknownst to Outlook, behind the scenes, goes to Entra, says, hey, Entra, I need a token. As we said, gateway. Gateway is a big part of our resilience, and you'll see why here, too. Like, it's a big part of cell-based architecture. It's an even bigger part of this, right? It's going to go and say, okay, the artist formerly known as Azure AD. It's going to, as I said, it does header rewriting, right? So it's going to rewrite login to Microsoft Entra to some other thing internal and say, hey, give me a token. Here's a request. Right. This thing will parse the request, as I mentioned. It's an expert at token processing and minting. It will parse the request, say, hey, as we mentioned earlier, directory proxy service, hit the core store, get me the artifacts I need to make a decision. Here are the artifacts you need. It's the good time. She's done MFA. She's done everything. Let's mint her a token. Nope. Right before we give her a token, the STS will call a clone of itself called the backup auth service. Same code running in different decorrelated infrastructure. So if the main STS is running in Azure ES, US East 2, this may be running in an M365 bare metal data center. Yes, Microsoft service at the end of the day, but not the same data center, not the same rack, not the same. So same, I don't know, Xfinity outage doesn't take both. No, we don't use Xfinity. We use our own backbone. But you get my point, right? The same infra can't take them both down. Right.
So it's completely different thing that is running. I remember when Scott Guthrie did a presentation, he said even the water lines, they have like a different water source coming in. So
cooling power,
cooling power, like so that they don't use the same water source, which can cause an outage on both sides if it heats up. So
calls it to that thing and says, hey, here you go. Here's an access token for that same person that I'm the same access, similar to the access, but this one is 3 days long, not 1 hour or 3 hours long. 3 days long. It says, hey, hold on to that one. Yeah. That one calls into a M365 storage. So that means that it's not new service with new authorization and new isolation. It is basically stored in the user shard in M365, just like your mail and your other things. Obviously, you can't see it, but it's stored there. Yeah. So you don't have to reinvent a new tenanted system or anything like this. Using the same existing structure, right? And it's stored there.
It's isolated as well, right? Then to that customer's partition of M365.
Exactly. And then we mint a token to her, so she gets that token she's expecting. She's happy. She's good, and an hour later she comes back. Unbeknownst to her, some big problem happens in Entra. So the core store is having problems. So the 2017 outage, okay, some bad thing is happening, and the core store is bubbling hot and incoherent. Or the STS is struggling, load amplification, the 2018 outage, one of them, right? Some big problem. The end result is the gateway sitting in front of all of this will get an incoherent response. An incoherent response means it's not a 200, 300, 400. Because 200 means, here you go, here's a token. Good. Success, right? Yeah. 300 means redirect. Go somewhere else, right? And then 400s are all, I am as a code, as an STS, I'm telling you, you are denied. 400 bad requests, 401,
forbidden.
What do you call it? Unauthenticated, 403 forbidden, 404 not found. These are all, the STS is saying these things, right?
Yeah.
500 is bad. Because 500 is the code below you that's answering, not you.
I don't know what's happening.
Yeah, this is Apache or IIS saying code is not there, right?
Unexpected error.
Exactly. That's not good. Right? A bad gateway, all those kind of not good things. When you see some end user even on a website, you know you entered in a very dark place, right? So, or you get DNS not found, host not found, some tragic network level error,
Right.
not even a 500, right? So you're getting some really bad responses, right? So what it's gonna do is gonna try another replica, right? So I don't know. So US East 2, let's go to US East 3 or US West 1 or whatever. Hey, can you serve me, right? And gets the same bad response. So now we know it's not a single cell issue. It's starting to smell like a tenant wide issue, partition wide issue, Entra wide issue. Not clear, right? So what it will do is on the third attempt, it will try the backup auth service. And remember, it's the same code, so it will take the same refresh token request, unpack it, understand, oh, this is the user requesting another token for exchange, blah, blah, blah. Let me check if I have something in the storage for it. Oh, look at that. There's a token already. Let me pick it up and send it back. This is important because there are scenarios that are not backed up. We are not, this slide is old. So we're not at 70%. We're actually at 90 something percent of auth now. But still, not 100%. Meaning that there are scenarios that are not covered by the backup auth service right now, certain SAML scenarios, that kind of stuff, that when it looks, it won't find a token cached. But most of the time, 90% of the time, it will find a token cached. Right? And it will pick up the token and it will send it to her, and she will be none the wiser. She'll get a token and she'll be happy. She'll go read her mail, and we will lie to the client. So some of your listeners will be like, wait a minute, you just minted a 3-day access token? The user is going to go away for 3 days and not check for access or anything? No, we did not. So for those of you, again, I'm going to go into the weeds of OAuth now. So again, this is an L200, L300. So watch Interchat episode 5 to understand this deeper, or go to a blog by our dearly departed friend Vittorio. But what it will do is, for those of you who don't know how this works, the way Outlook knows that the token is 1 hour is not because it opens it. It never opens it. In fact, the token is not intended for Outlook. Outlook takes the token as is and gives it to Exchange. Exchange cracks it open. Outlook doesn't do anything. So how does Outlook know that it's supposed to come back in an hour?
Right.
There's a header. So we lie in that header. We say the token is an hour, but it's not. So Outlook will just come back in an hour, even though it is actually longer than now. So then, and that's how it works under the covers. There are ways for customers to turn this off. This is the default behavior. We really try to err on the side of continuing auth. So if you had a CA policy that says, if Merrill is not a member of this group, don't MFA him, and then there's a outage and now you're being served from the backup auth service and Merrill comes back, we will assume you're still not a part of the group and you don't need to do fresh MFA. We will continue the auth. Some customers say that's not acceptable. If you're not able to verify everything that I said, deny the token. There's this checkbox in the product called resilient defaults under session controls. You can turn off. We do not recommend you do that because it degrades your resiliency. But if you need to for any regulatory compliance reasons, you can. And of course, untold in this is fresh auth kills all of this. So if you have a sign-in frequency policy, for example, that says demand fresh authentication every 20 minutes from users or every 3 days or whatever, you're making their ability to succeed with this lower.
Right. And this is, so when this does kick in, say there's an Entra outage, obviously you wouldn't know, but there is something bad happening. The backup service is automatically kicking in and giving tokens to the user for
one of the
refresh.
hardest things for people to internalize, because they keep asking, when does it kick in? Whenever it can't get a coherent response. So people still have the mindset of like on-prem domain controllers, and I have to fail over and cut a switch and manually move the load balancers from. Nope, this is all happening automatically per request. There's no software engineer sitting there and saying, oh, let's cut over these. We can do that. We have the controls and the gateway to say, okay, let's move over everybody from here to there. But we're not waiting on human judgment here. This is simply the request got an incoherent response. There is no reason to even wake up an on-call engineer. Let's go get a backup token. Yes. And of course, there's telemetry that tells us there's degradation and other stuff like that. So we'll wake up our own on-call engineers. But there's no human judgment involved in switching over or switching back, either way.
As a customer, I guess the only time you might notice is some people are already logged in. Whoever's logged in is fine. But when someone new tries to sign in, they are not able to sign in because they've never minted a token. The backup auth service doesn't have the token.
Correct. There is good news in that the backup auth service does show up in the sign-in logs. So you can actually see it working for
Oh,
you.
nice.
So that is one of those.
Because before you wouldn't even know if it was kicking in.
Yeah, so it's right here. So you can see now in the sign-in logs, you can filter by, I think it says Entra Backup Auth, not Azure AD Backup Auth now after the rebrand. But you can actually
Right.
see it right now in the sign-in logs.
So if you use the token
and it will
issuer
be
type,
in the non-interactive, not the interactive. Because
right.
obviously interactive doesn't work. But in the non-interactive, so if you ever suspect, as you said, there were a couple
Yeah.
of failures, and you can go look
Yeah.
here and see if it's But that's one cool transparency thing we do as well. So kind of you can see when it's working for you. By, again, token issuer type, which is Entra, or if you have ADFS, it will show you ADFS traffic. And if we served any traffic from the backup auth service, it will show you.
So on the backup pod, just so it's clear in people's head, the backup pod service is very close to being like a replica. It's not a replica of Entra, it's just keeping backup
It's a
token. So
replica of ESTS, of the STS.
ESTS, right? It doesn't have its own sort of login page at all, right? Like
Nope,
no one
doesn't
will
have
ever
state.
see a login
It's
page.
unable to look up group membership. It's unable to look up CA
Yeah.
policies. All it's able to do is look at if a token has been stored at it,
Yeah.
they receive a request, decipher if that request maps to that token, and then serve it back.
Yeah.
Unless there's something explicitly in the request that says validate everything, and then it will just say, no, I can't.
Right.
Right? Because it can't validate anything. Like it can't.
It
like, I think
doesn't.
the
It
only
doesn't
thing
run
it can.
CA policies and other things at
There
that
is
time,
one thing
right?
it can do, which is IP. Right? It
Okay.
can see your IP. So if there's a CA policy that says require trusted IPs or come from these IPs, it sees your IP, so it's able to make a judgment call on that one. But for example, for MFA, it can't look up your phone number to initiate MFA.
Right.
Like it can't even do any of that stuff. Like require PIM, none of that stuff. It can't invoke any of that stuff.
It's doing the bare minimum.
Yeah, it's doing what can be done within the STS. It is not a replica of all of Entra. It is only a replica of the security token service.
Yep.
And one of the things we didn't talk about, which I'm glad now that you asked the question, is why did we do it this way?
Yeah.
Like, why didn't we just mint a token from this one? Why did we pass a purple token and stash it there instead of simply having this backup auth service itself just mint its own token? There you go.
Yeah.
Right?
Yeah.
It's a very important point for people to kind of internalize. We debated this, right? And when people ask us all the time, like, is it safer for me if I'm trying to really be up all the time to put Entra and Okta on top of it, or Ping and Entra side by side to a server authentication, right? And no dissing the other products, obviously. And no, it's harder for you. So, if we had minted a different token from this, it would have been a different issuer. For those of you who are into the mechanics of tokens, auth tokens, access tokens, refresh tokens. So the access token would have had a different issuer, different certificate, which means Outlook will get the token. First of all, you'll have to teach Outlook to request a token from one URL or another. So you have to change Outlook now. But let's say Outlook gets the token. When you submit the token to Exchange now has to trust tokens from Entra or Entra 2.
The other service,
right? Or Entra or Okta. Or Entra token signed by this signer or that other certificate. Right? So now we have to change the whole app ecosystem to get resilience. Right?
Yeah.
You have to get all the clients that request tokens. Mm-hmm. You have to change all the servers that receive tokens, which would have taken decades to finish.
Yeah.
So that's why we went this path, because this is kind of like the least intrusive to them. Because we don't have to change the whole eco. Like one of the challenges people ask about Depop, for proof of possession for binding access tokens, or continuous access evaluation. One of the challenges in the industry is that they require changes of the app. Those take years and years and many, many years. And 7 years from now, we'll still have a lot of apps not supporting them, right? This was a very kind of elegant, quick solution that helped us to provide a lot of resiliency without rewriting the whole Microsoft ecosystem or your app ecosystem as well, right?
Yeah. Yeah. The last thing Microsoft wants is Teams going down because Entra went down, right?
Yeah. So that's the second component. So we covered the cell-based architecture and the backup auth service. The third piece I want to talk about is a derivative of the backup auth service, which is because we achieved the backup auth service, we were able to do this other creature, which is regional isolation. So this is a bit of a detailed slide. I'm not trying to focus on the right side as much, but for those of you who don't know, this is kind of how many levels of isolation and protection. This is about protecting your workloads in Azure specifically. workloads in any infra in general have this amazing thing, which is they just run all the time, all the time. Like they never, and very little changes. It's not like a user who's going to get in the building, get out of the building, do fresh MFA or not do fresh MFA or trusted device or not. They're always running the same thing. You put them in all the time, pretty much, right? Unless a malicious actor steals their credentials or something, right?
Yeah.
So in that context, for those of you who don't know, one of the best resilience investments you can do, I'm trying to make this practical also for people, right? Is use managed identity. If you're not using Entra managed identity already or Azure managed identity already, shame on you. You should be doing it in anything that supports it. So I don't know, Azure functions, VMs, everything has it. Please do it. It's a huge, not just is it cool, originally it was invented for secrets management to help you not have to deploy secret on a VM with a certificate to go call Entra and authenticate a certificate to get your first token.
Keep rotating it and all that.
Exactly. This automatically gets you the first token. You don't even have to worry about how the hell you got it. You just get a token for whatever you need. Like let's say you want the front end to wake up and talk to SQL Azure. With this approach, you just automatically get a token to SQL Azure that is exactly scoped for what you are allowed to do, and then you can call your backend and get what you want, right? And I don't know. Meryl will do an episode about managed identity one day. I'm signing him up for it. But what's happening here, what I want to talk about here is more is what we don't know is when you do get that token, it is not coming from primary STS Entra. It is actually coming from an in-region cache that you have. And so you basically have a mini ESTS serving you tokens in region for your needs, just like the backup auth servers did for the Office scenario you mentioned earlier. Now imagine that same thing now deployed in every Azure region, so that after the fresh auth that you do the first time, there's a long-lived kind of token you can keep getting from that thing, right? They keep serving you what you need. You're working fine, unless the authorization rules change. You really like somehow change the ARM. You go to ARM Azure Resource Manager and change the, what's RBAC assignments for this thingy. It's gonna keep working just fine, and this thing is super, super resilient. So even though Entra itself might be drowning, you'll discover your workloads felt nothing in US West 3 because Entra they barely talk to Entra at all. They do come to Entra when there's a fresh auth, when they first get the initial token. After that, it's just resilient.
Right. So this is if you're building custom apps and all of that, right? It's
workloads in Azure, any custom app.
A lot more secure than using a client ID and secret, because that needs to be validated all the time.
Correct. Client, and then specifically password secret is bad, and then certificate secret is just how are you going to get that secret on the VM?
Yeah.
Right. Some of you on the audience are putting a certificate in a file and take it with them to production and dropping it on the machine
on your desktop.
And that file is absolutely a nightmare. That's you shouldn't exist because it's in the developer's machine. It's in the so no. So we can have a separate deep dive on that one. But that was originally why it was invented to better secrets management, but it's also better resilience as well. So
right.
This is kind of go ahead.
For me, that's a new thing. Like managed identity for me has mostly been about not having to rotate certificates and like do all of that. But there's a huge story on availability as well.
Correct. And this is like again another war story. The Near-Outage of 2021, December 2020. This one was a Near-Outage because, and I wanted here to show you kind of like the relative strength of each of them, right? So the red at the bottom of this chart is what the actual availability of the STS was. So at this was like a certain part of the US, not everywhere, right? It was running at 82%, right? And then backup auth service was running at 97%. Well, it's just kind of the delta between fresh auth and backup auth, right? That most people were getting tokens just fine, and some people getting failures, So even within your own user base as a customer, most of the users are fine, and then there was 3% calling help that's like, I can't get it, and what's going on, right? And you're like scratching your head, what's going on? It's going to play out the same way within your world, right? But look at managed identity, 99.6%. They like barely saw anything, basically, in terms of an outage altogether, because they're just served locally from the copy next to them, and all they do is continue on. Not a lot of parameters change with what they're doing, right? And then the aggregate view that the world saw was 90%, right? This is combined, and of course, the 82 includes things not covered by the backup auth service, so everybody as a whole saw 90%, and 10% degradation in Entra in any region will be seen, People will just talk about it. Down detector. People will be like, gossiping about it. Even of course, we will try to communicate obviously our best, but but it's interesting because as you see, the things that are covered by these mechanisms. That's why the point is that that's why these mechanisms give us hope. So knock on wood and all that stuff. But it's really because they actually do make a difference, as you can see here in some of these things, right? So, and that's kind of how we get to this kind of final picture that I started with, right? Is like, it's not just magic, it's not just hype and, oh, look at us, we're so smart and so cool. It's also a,
what's this two chart? Like the first one shows that the uptime has been close to 100% for users.
Yeah, this is the user experience. This is user uptime experience. This is how they experience Entra. Is they saw it 100%. They saw no failures at all.
Right.
Whereas under the covers, we were at 99.97, for example. But because of backup auth serving most of the traffic, for example, since it's users, probably backup auth, right? They felt nothing, for example. And this is kind of how the point is we're layering these things. Cell-based architecture is the foundation, backup auth service on top of it, right? And these layers help us kind of deflect a lot of these outages. Not deflect as in they never happen. It's more absorb. You're able to kind of be resilient in the face of these things, as opposed to simply only just doubling down on I'm never going to go down, right? Like we have other resilience measures, like for example, the preventative stuff, like active DNS, active CDN. DNS and CDN are kind of like the two foundational things that people need to get to you, right? When you hit the login, first of all, DNS has to resolve to us.
Yes.
And then when the page renders, that has CDN, that has the logo, the page, the UI elements, the JavaScript, all that is CDN, content delivery network, right? And so, but that's all preventative. We're trying not to have an outage. But this is basically saying if ESTS can't load its front end page to get you or whatever, then can we route the request to backup auth and get you a token there? So it's a defense in depth kind of resilience measure.
Yes. I mean, for me, it's been fascinating being inside Microsoft to see how much thought and effort goes in. Like having worked in an enterprise, and when things go wrong, you rush to fix it. And then things do sort of just eventually, people forget about it and you move on until it sort of happens again. But having been at Microsoft now for 5 years, I sort of see all of the work that does that happens behind the scene to try to learn from it and to fix it. And you see it in sort of these results of, the work that goes on and also the outside, like how Microsoft communicates and shares all of this information, like the whole cell-based architecture, safe deployments, what we were doing, and explaining all of that. So for me, that's been a really fascinating thing about what happens. And I'm sure we'll do one on like the whole SFI things that are happening today in the future at some point. But it's fascinating how thorough, like there's time spent all the way, like with all the execs and everyone involved in leadership teams to make sure Microsoft learns from these mistakes and it doesn't sort of happen again.
And the level of innovation you see here, right, is massive in terms of the amount of engineering time and effort and thinking. And sometimes it's at the cost of features. Like people will be like, oh, when is this feature coming? I mean, you are very familiar with this from your work in the application space, right? Working with developers and working with our applications team. There's a lot of features. Customers are like, oh, can you add more SAML customization? But you know that team is so heads down on securing the app ecosystem that they're very focused on that part because, like if we get consent wrong or, app policies wrong, a whole lot of bad happens ahead of that one nice feature. And not to dismiss any feature, but I think, yes, you kind of start to see also the kind of like the wisdom of how some of these decisions about like prioritizing, investing in some of these things. And some of these things took years, to be fair. Like a backup auth service, like you saw like the slide, backup auth service back in 2021 was only serving 70% of traffic. Now it serves about 95% of traffic or something like that, right?
Yes. Nice. Awesome. Thank you so much, Tarek. I think this is we broke the record for the longest episode, maybe.
Really?
About an hour and a half.
Oh, okay.
So, it depends on how much I like the edits I
You're
do.
gonna edit it, I'm sure.
But yeah, like cool stories and the behind the scenes of how Microsoft works and how these things play out when they happen in sort of real time. I've never been in a live site, so but I have joined some of the bridges when we have had some.
I'll drag you into one day. I was dragged into one thing 2 weeks ago.
Okay.
They still ask me about things. I'm not supposed to be in bridges anymore.